Okay, good evening, everyone. My name is Kivanesh, and I'll be presenting the first part of our database project, which focuses on the food and beverage business scenario. I'll cover the case scenario and the specific business rules we've defined for the project. Our chosen scenario is centered around ABC Bistro, a mid-sized restaurant that serves a variety of dishes, including local favorites and international meals. The restaurant provides dining, takeaway, and online delivery services through its mobile app. Despite its growing popularity and customer base, ABC Bistro faces several operational challenges due to its reliance on manual processes. One major challenge is manual order processing, where errors like incorrect dish quantities or mismatched customer details are common. Additionally, the lack of centralized records makes it difficult to track order histories and analyze customer preferences. Another issue is inventory mismanagement, where ingredient stock levels are tracked manually, often leading to overstocking or shortages, which delays the food preparation and affects customer satisfaction. Lastly, the restaurant struggles with limited sales insights. Promotions and combo offers are often based on assumptions rather than data-driven trends, which reduces their effectiveness. To address these challenges, we've proposed implementing a relational database system. The system will streamline operations by automating order tracking, updating inventory in real time, and generating actionable sales insights. For example, the database will analyze frequent order dish combinations, helping the management create attractive combo meals and promotional offers. Overall, the solution aims to enhance operational efficiency, improve customer satisfaction, and drive business growth.
Next, I'll outline the key business rules we've defined for this scenario. These rules guide the design and implementation of our database to ensure it meets the business's operational needs. So the first one is customer management. Each customer is assigned a unique customer ID and must provide their name, phone number, and email address when registering. Customers can place multiple orders, but each order is linked to only one customer. The second one is order processing. Each order has a unique order ID and can include multiple dishes, with each dish having a specified quantity. Orders also have predefined statuses such as pending, preparing, completed, or delivered. Third one is menu management. Each dish on the menu has a unique dish ID, a category such as appetizer, main course, dessert, or drink, and attributes like price and availability. Dishes that are marked as out of stock cannot be included in customer orders. The fourth one is inventory management. Ingredients are tracked using unique ingredient IDs. The database updates stocks with levels automatically when orders are placed and generates alerts if any ingredient falls below its minimum threshold. The fifth one is sales and promotions. The database records sales date by date, order, and customer. It identifies frequently ordered dish combinations such as pizza and soda to create promotional offers. Additionally, discounts on combo offers are capped at 50% to ensure profitability. These business rules ensure that the database supports the restaurant's operational goals, maintains data integrity, and provides actionable insights for decision making. That concludes my part of the presentation. I've explained ABC Bistro's challenges and proposed solutions, as well as specified business rules we've defined to our guide on database design. Thank you, and now hand over to my teammate to discuss the next part of our project.
Good evening. My name is Wang Yushan, and I'm going to walk you through the entities, relationships, and the constraints we implemented in our database system. So to begin, let us first look at the entities in the database. So for the order tables, each order will have their own identifier, orders ID, along with attributes such as order date, order status, and delivery address. The customer ID here acts as a foreign key linking to the customer table. For the customer table, every customer is assigned to a unique customer ID as well, and the table also contains customer information like customer name, phone number, and their email address. And the sales table, it has a unique identifier, sales ID, and the order ID here is a foreign key linking each sales to an order, and the attributes such as total amount and sales date. Next, let's look at the dish table. We have the primary key dish ID and the dishes information like the name, categories, price, and available status. And the order detail table is the one that connects the order table with the dish table. We call this a junction table. It uses order ID and dish ID as foreign keys to link to the respective tables, detailing the specific dishes in each order along with their quantity. Moving on to the ingredient table, each ingredient is assigned with a unique ingredient ID and the name, stock level, and minimum threshold. And the dish ingredient table here uses dish ID and ingredient ID as foreign keys to connect to their respective tables. This table also specifies the quantity of each ingredient used per dish. Next, let's look at the relationship between these entities. One customer can have many orders, but an order can only belong to one customer. So the relationship between customer and orders is one to many. There is also a one to many relationship between orders and order detail, where an order can have multiple dishes. Similarly, a dish can appear in many orders, which indicates a one-to-many relationship between the dish and order detail table, and a one-to-one relationship here, where each order corresponds to a unique sales record. Also, a one-to-many relationship here representing one dish can have many ingredients, and a one-to-many relationship here as well, showing each ingredient can be used in multiple dishes. Now, we will talk about the constraints applied to maintain data integrity. In the orders table, the order status is restricted to specific values such as pending, preparing, completed, delivered, to prevent invalid or inconsistent data being entered. And in the sales table, total amount entered must be greater than 0 to ensure accurate financial records. And the quantity column of the order detail table here must be greater than 0. For the dish table, categories are limited to valid options like appetizers, main course, beverage, and dessert. And the availability status, make sure a dish is marked as either in stock or out of stock to avoid confusion. And the dish ingredient table, here the data value of the quantity of ingredients used per dish must be greater than 0. And lastly, the ingredient table, both the stock level and minimum threshold values must be greater than or equal to 0, since it cannot be a negative value here. And that's all for my part. Thank you.
Good morning to Dr. Hafiza and Dr. Matthew. Now I'm going to present the part 2 section of the sixth query. So at the first beginning, this is our question 1 and is shown by order join. So select orders ID, customer name, order detail, dish ID, order detail quantity from orders table and join customer on order customer ID equals to customer ID. Left outer join order detail, orders on order ID equals to order details, order ID. So this result is showing the customer details. So next question, group by function. By using group by function, so at the first beginning, select dish categories, sum sales total amount as total sales from sales table and join orders on sales order ID equals to orders order ID and join order detail on orders order ID equals to order detail order ID. Join dish on order detail, dish ID equals to dish ID group by dish categories. So this result is showing the total sales on each category. So next question, by using string pattern matching and date. So select order ID, customer name, order date, order status from orders table and join customer table, customer ID equals to order customer ID. Where to chart the order date equals to 2024 and the order status equals to pending or preparing. So this is the result showing the orders pending and preparing in the period of 2024. So next question, by using having or an and query. So at the first beginning, select dish name, dish categories, dish availability status as stock status from dish, where dish category equals to appetizer or dish category equals to dessert, and dish availability status in stock. So this is the result that showing the stock status of category appetizer and dessert. So next question, and this consists 2 subquery in 1 query. So at the first beginning, select customer ID, customer name, and select count of the order ID from orders table, where orders customer ID equals to customer ID as total orders by customer. And still selecting, select sum sales total amount from sales table, join orders on sales order ID equals to order ID, where orders customer ID equals to customer ID as total spend, and orders order date from customer table, join orders on customer ID equals to order customer ID, where to chart the order date equals to 2024 order by total spend descending. So this result is showing the total of customer, total number of orders, and total spend order date in the period of 2024. So the last question, by showing the combo meals. So at the first beginning, select dish 1, dish name as dish 1, and dish 2, dish name as dish 2. Count distinct order customer ID as customer frequent order from orders table, and join order detail or OD1 on order ID equals to OD1 order ID. Join order detail OD2 on order ID equals to OD2 order ID, and join dish 1 on order 1 dish ID equals to dish 1 dish ID. Join dish 2 on order detail 2 dish ID equals to dish2 dish ID, where the D1 dish ID whether is smaller than D2 dish ID, grouped by D1 dish name and D2 dish name, ordered by customer frequent order. So this result is showing the combo meals with frequent of customer order, and using D1 dish ID smaller than D2 dish ID to avoid the overlapping result. That's all of my part. Thank you.
Well, good morning, Dr. Nafiza and Dr. Matthew. I'm Guru here, and I'm going to talk about the tables just in general. So here is customer table. You can see here there's customer ID, customer name, customer phone, email. So for customer ID, it's the primary key. For customer name, here's just string. And for phone, it's formatted in Malaysia way. And for email, here you can see it. And next, I'm going to talk about the order. So the order page here, you can see order ID, customer ID, order date, order status, or delivery address. For order ID, is the primary key here. Customer ID just a foreign key, and order date, the status. Order date is just date, and order status is it can be changed during a service. So it can be pending, complete, preparing, or delivered. And delivery address here. It's not really needed if the customer walk in, but if for delivery, it's a must. The next table, I'm going to talk about dish. For dish, you can see dish ID, dish name, categories, price, and availability status. So with dish ID, I haven't mentioned before, but actually the ID is just 3 significant figure. And here's dish name, string. Categories, we have 4 categories in our restaurant. The first one is appetizer, second one is main course and beverage, and the last one is dessert. For price, it can be up to 2 decimal place, but you cannot see here, but I will show at the last one. Availability status, it can be updated into in stock or out of stock. If the dish is out of stock, customer cannot order it anymore. And next one I'm going to talk about is order detail. For order detail, it's actually just a link table for order and dish. You can see here order ID and dish ID, and the last attributes are quantities. For order ID and dish ID, it's both primary key and foreign key, and the quantity can be updated. And the next table here, I'm going to talk about ingredient. So here we have ingredient ID as primary key, ingredient name, just a string, stock level, and minimum threshold. So here I'm going to talk about dish ingredient. It's a link table between dish and ingredient. You can see here dish and ingredient ID, and the last one is quantity used per dish as attribute. Dish and ingredient ID is both primary key and foreign key for quantity used per dish. It is used to see which ingredient is needed for a dish, which dish. And the last table here, I'm going to say is sales table. So here we have sales ID, order ID, and total amount, and last one is sales date. Sales ID is formatted into 4 significant figure, and for order ID is a foreign key here. And total amount, as I said just now, it's 2 decimal place, and just I've updated the content, so I can show you that it's 2 decimal place. And here's sales date, formatted as date. So this table is just for you, used to find if there's any error during the marketing or anything happen, we can actually just use this table to find which order ID it is. All right, that's all for my presentation and my team presentation. Thank you.